Have you ever wondered if you could spread a wave? No, not that kind of spreading. Let me explain. Imagine you have a gun, right? And we're not going to shoot anyone, right? We're going to perform a specific experiment that I want you to think. Imagine you have a gun and you have a piece of cardboard or a piece of board that is cut into a specific shape. Now, you take your gun and you position a screen that is at a certain distance, and then you put that board and then you put your gun behind it. Now, as you shoot the gun, bullets are going to be fired and they're going to hit that specific board. But what you're going to notice is that some of the bullets are just going to not enter at all, but you're going to form a straight line that's going to appear on that screen. What you shot, the amount of bullets that enter through that hole are the bullets that you're going to see on that screen. And they shouldn't surprise you, right? You can't expect, the bullets to just hit somewhere where you didn't expect them to do. And that's expected because bullets do not spread. But imagine if you were to shine light on that, right? If you were to shine light on that, you'd discover that light would spread into a region known as the geometrical shadow. That is, instead of having one single beam shine through that hole, is going to shine every single way. So if you have a slit, so a slit is what we refer to as that opening. That opening is called a slit. Light is going to spread into the geometrical shadow, and that geometrical shadow being a space that you don't know, and that is what we call diffraction, the spreading of a wave into a geometrical shadow. And that happens when it passes through a slit or past an edge. So it can be an edge and your wave passes through that edge, and then it goes and it spreads where it wasn't supposed to be, because you realize we're supposed to be at top, but it's spreading into a region where it didn't go. Or if you have a vertical slit, your light will spread horizontally, meaning that what you're going to see is that you're going to see a pattern that will be like that, because you're shining a vertical beam of light, so it should spread horizontally. But if you have a horizontal slit, your light is going to spread away from the slit as possible. So it's going to form a vertical strip, right? Like that. And if you put a dot, it's going to form a big circle. So diffraction is basically defined as the spreading of a wave into a geometrical shadow as it passes through a slit or past an edge. A geometrical shadow being a space where it once wasn't. So it's very important for you to understand this concept, because we're going to bring about specific effects. As you can see, we're going to do certain experiments that compare the gap width relative to the wavelength in the next video. But for this video, I just wanted to introduce you to the concept of diffraction. It is the spreading of a wave. We want to spread it into a region that it normally wasn't, so that it can reach that specific region, and only waves can partake in this specific property where they spread out. As you saw that the bullets didn't just spread elsewhere, it was only waves which could do that. And it's a very important observation that led us to discover this effect of diffraction. Thank you guys for watching, and I'll see you in the next one.